Hello, hello, and welcome to this assignment. This assignment is called Vector Word Problems. I guess I put vectors word problems. And let's kind of get this started. I'm going to give you help in this video. I'm going to show you how to get started. I'm not going to give you any answers in this video, but I will help you with the setup for a lot of these questions. So in question one, question one hasn't even started yet. The setup for questions 1 through 5, you have 4 teams playing a game of strength, all right? They're playing a 4-way tug of war. And I've tried to show an example of this during class. So maybe if you remember the videos I've shown. Each team, so you're playing a 4-way tug of war. Let's look at our 4 teams. Team A pulls northeast with a force of 4 newtons. Okay, so northeast, we're going to just say is a straight out 45 degrees. Directly, it doesn't really clarify. We're going to say it's right in the middle of north and east, so that's 45 degrees. And I tried to draw this, with the length of 4. Obviously, it's not going to be perfect, but because there's no grid. But there we go. This is Team A. Team B pulls northwest with a force of 4.5 newtons. So here, Team B needs to be a little bit longer, not by much. And northwest, we'll say, is 135 degrees. That's right in the middle of 90 and 180. Team C is your weakest team. They are going 3.6. So this one needs to be a little bit smaller. And that's called 225 degrees. And Team D pulls southeast, 4.4. Another very strong team. Almost as long as Team B. And we say this is 315. So we look at this, which team is going to win? Now, clearly Team B is the strongest. Okay, but Team B is also going up against a kind of directly opposite Team D, which is almost just as strong. That makes me think B and D might kind of neutralize each other. Remember, the strongest team does not always win a 4-way tug of war like this. Now over here, Team A gets to go up against a weaker team. We'll see, man. We'll see exactly which team is going to win. And, we'll see. My gut's kind of telling me Team A. But then Team B is a little bit stronger, so I don't think it'll be a decisive victory, Fred. I don't even have to do this, but my guess is the resultant's going to be kind of like this. But still in Team A's favor. We'll see. All right. So use this information to answer the question. So to put this into mathematical language, it's pretty easy at the beginning. So Team A, 4 newtons at 45 degrees. Team B is 4.5 newtons at 135 degrees. If you look again, so here's the rest of them, 225 and 315. Team C, the magnitude, the size of that vector is going to be 3.6, but then the direction also very important, the direction 225 for southwest. And then Team D, 4.4 is the magnitude, and the direction southeast we said was 315. Okay, so here's all of these vectors. Here's the 4 teams all written as a vector with polar coordinates. And basically, I need to add all 4 of these things together. The problem is you cannot add polar coordinates, okay? I can't just sit here and add these all together and get an answer. It'd be outrageous. It just doesn't work. So let's remind ourselves of the steps. Here's your steps. All of these, and the questions even kind of break it down into the steps for you. We have to convert, here I'm going to write down the steps here. So here's our steps. First off, we're going to have to convert every single one of these into rectangular. Once they're in rectangular form, then we can add all the rectangulars together, add up all the A values and all the B values to get what's called a resultant vector. Then we have to convert that answer back to polar. So you're going to see how this assignment kind of walks you through the steps. Here in question 2, we have to convert each team's polar vector into rectangular vector. So real quick reminder. So for Team A, I'm going to take 4 times the cosine of 45, which that comes out to 2.83. And then I have to take 4 times the sine of 45. And that actually also comes out to 2.83. 45 degrees has that effect where these numbers come out the same. Okay, so you're going to do that for all 4 teams, get them all in rectangular. Once you have in rectangular, you'll be able to add up all the horizontal components. You'll add up this horizontal plus this one plus this one plus this one. That'll give you a horizontal answer. Then you'll add up all your verticals, this vertical plus this vertical plus this vertical. That'll give you a vertical answer. Okay, that's your answer to question 3. What is the, okay. Well, and once you have this, now you'll have to take this rectangular vector, and to answer question 3, you'll have to turn it back into a polar coordinate. Okay, and that'll help you answer questions 3, 4, and 5. Okay, and one last thing I do want to look at, I want to also look at questions 8 and 9, just help you with the setup. Okay, a motorboat crosses a river due north at a velocity of 60 feet per second. Okay, so if we have north, west, east, south. By the way, draw pictures for these, all right? Drawing pictures helps a ton. So you have a motorboat crossing a river north at 60 feet per second. Now here it says the resultant velocity of the boat is 81 degrees. All right, so this is 90 degrees. The actual resultant, this is where the boat is headed. The boat is headed straight north. But when you look at what actually happens is the boat actually gets pushed off course a little bit by the current. It goes to 81 degrees, at 60.75. Now here, basically, just to kind of lay this out for you, here you're going to actually have to subtract. Okay, the idea is if you took the velocity of the boat plus the flow of the current, that would give you the resultant. Okay, but here they actually tell you the boat and the resultant, and you have to find the current. Okay, just using a simple algebra, what that means is that the current, then to find the current, we would have to take the resultant minus the boat. Okay, and so this is what you're going to have to find. You're going to have to take the 60.75 at 81 degrees, convert that to rectangular, and then subtract that by the 60 at 90 degrees. Okay, you can't subtract these as polar coordinates. You've got to convert this one to rectangular, convert this to rectangular, subtract the horizontal components, subtract the vertical components. That will give you the answer of how strong is this river flowing and in what direction to the nearest degree. All right, so best of luck on this. Take care.